With the method of joints, we figured out how to find the internal force of every member of a truss. The method of joints is relatively straightforward. For each joint, set the net force equal to 0 and use this set of equations to solve for all of the truss tensions. However, its simplicity also has a downside. You can be working with a really large number of linear equations that must be solved either simultaneously or through some method of linear algebra. What we are going to be doing today is a different method of finding the internal forces of truss members, called the method of sections. So to start, we are going to make many of the same assumptions that we did with the method of joints. We are going to assume that the truss is made up of members and that these members have an internal tension. We are again going to assume that all of the internal forces are tensive forces, and again, if our solution gives us a negative, that means that it's actually compressive. Only this time, instead of looking at a single joint at a time, we are going to be looking at groups of joints that are all connected together, called a section. Now, like with the method of joints, we will end up finding the net forces on these sections and set those net forces equaling to 0. However, a section is not a point like the joint was. A section is spread out, which means that the forces have locations, which means that forces can create moment. And so we will also need to find the net moment on these sections and set them equal to 0. So to start off, the method of sections sounds more complicated than the method of joints, and in a way it is. We are seeing additional sum of moments equations in there. We also will need to take care to select which sections we use. However, the method of sections does have one enormous benefit, and that is you do not need to find all of the internal forces. With the method of joints, we often found ourselves needing to solve for member A, which would let us solve for member B, which would let us solve for member C, which would let us solve for member D, etc. With the method of sections, if we are clever about how we select our sections, we can find the information that is most relevant to us. Indeed, through a process known as inspection, which is basically using common sense, we can often look at a structure and guess where is it most likely to fail. In other words, which members are going to be under the highest tensive and compressive loads. And generally speaking, if we can find a member like that, we can focus on that member. That is the member whose internal force is most important to us. So, the steps in solving using the method of sections. First, you make a section. Generally speaking, when you use the method of sections, there is one or a couple members that you are particularly interested in. In most of the homework problems, these members are the ones explicitly shown or explicitly stated. But in a real structural design, there are often places where we recognize that will be a weak point, and so those are the members that we want to check. The slice that we select must go through that or those members. We also sometimes will need to make to use multiple sections to solve for make multiple slices and do the method of sections multiple times. This does, of course, eliminate some of the advantages of using the method of sections, but still for a very rather complicated truss, this can still be an advantage. Next, each section will have potentially some reaction forces, potentially some load forces, and some tension forces of the cut members. Now I need to clarify, it is only the cut members that apply a force to your object. For the members that are whole inside your section, Newton's third law would apply. If they apply a tension in one direction on one part of the section, they must apply an equal force in the opposite direction on the other side. Net force is equal to 0. Furthermore, since the internal tension force of a member is always directed along the direction of that member, the net moment is going to be 0 as well. So once you have those forces, and once you have the moment, having selected a point that you believe is best for moment calculation, set them all equal to 0, you will have a system of equations. Solve those systems of equations.